Hello class. Today we are going to look at section 10.5, which covers the quadratic formula. This is just another way to solve quadratic equations, find zeros of quadratic functions. There's actually something in there called the discriminant that will be very helpful as well. Learning targets for today. So our first learning target is we're going to use the quadratic formula to find solutions to quadratic equations. So we've talked about a couple different ways to do that. We've talked about solving by factoring, solving by completing the square, solve using square roots, and now we're going to solve using the quadratic formula. The great thing about the quadratic formula is it works for all quadratic functions. It's just typically a little more work, it's a little longer, but it works for everything. Second learning target, we're going to use the quadratic formula to find the zeros of a quadratic function. And third, we're going to evaluate the discriminant. Okay, we're going to evaluate the discriminant to determine how many real roots a quadratic equation has and whether it can be factored. So discriminant is very helpful in finding how many roots we have. We'll talk about that. Two vocab, the discriminant and the quadratic formula. Let's get started. First, the quadratic formula. This is something you really should memorize. Something you absolutely should memorize. So our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This works for a quadratic function that is in standard form. As you'll see, if we have ax squared plus bx plus c, we plug the a in here and here. We plug our b value in here and here. And we plug that c value in right here. So we'll take our three values that we have, our a, our b, our c, we'll plug it into the formula, and then we will solve for x. Another very important thing to see, since we have this plus or minus right here, that will typically give us two solutions. Now there is a very specific time when this will only give us one solution, but that depends on this b squared minus 4ac, which is actually called the discriminant, which we will talk about soon, as in later in this video. Let's look at an example. So let's say we had this quadratic equation here, x squared minus 10 plus 3x equals 0. The first thing we want to do, just like the first thing we did when we were factoring, is we want to make sure that this is in standard form. So let's go ahead and write that in standard form. So x squared, then we're going to put our plus 3x minus 10 equals 0. Now we are in standard form, and we're going to be able to identify our a, our b, and our c value. Let's go ahead and do that. Our a value is going to be 1. Our b value is going to be 3. And our c value will be negative 10. Now we need to plug that a, b, and c value into our quadratic formula. So again, our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and plug in our values. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Alright, our a value, which is 1, goes in here and here. Our b value, which is 3, goes in here and here. And our c value, which we found to be negative 10, goes right here. And after that, it is just all about simplifying this equation. Or this formula, I should say. Let's go ahead and do that. A little note before we get started on simplifying this. This is another one of those situations where it is very important to show all of your work, okay? On testing quizzes, I want to give partial credit. So partial credit will be given for plugging it in correctly. So show me that you plugged in the numbers correctly. And then each step down, I'll be looking for things to award points for. So show every single step, take it one step at a time. Okay, showing your work is very important on these. Great, let's get to work. So, x is equal to, that'll be -3 plus or minus the square root of 3 squared is 9. And then it's -4 times 1 times -10. -4 times 1 times -10 is a positive 40, all over 2. So that leaves us with x is equal to -3 plus or minus the square root of 49 over 2. Or x is equal to -3 plus or minus 7 over 2. All right, so we're almost there. But there's a very important thing we have to see here. So like I was telling you on the last slide, since we have that -b plus or minus, what we actually have here, where can I rewrite this? I'm going to move this up here so I have a little more room. We actually have two equations here that we need to solve. The first equation that we need to solve is the positive case. Let's go ahead and do that. So x is equal to -3 plus 7 over 2. -3 plus 7 is 4. 4 divided by 2 is 2. So one of my answers is 2. But we also have to account for our negative case, where we have -3 minus 7 over 2. So, x is equal to -3 minus 7 over 2. -3 minus 7 is -10. -10 divided by 2 is -5. So my other answer is x is equal to -5. And that's my final answers. So the solutions to this quadratic equation is x is equal to 2 and x is equal to -5. If we were to graph this function on Desmos or your graphing calculator, you would see it crosses the x-axis at 2 and -5. If we were to solve by factoring, we could solve by factoring here. You would see that the answers are 2 and -5. So this is just another strategy for finding those solutions. Great. Let's move on to the discriminant. Actually, I want to do one more example. Let's do one more example first. So here we have y is equal to 3x squared plus 2x minus 4. Okay? And we want to find the zeros of this function. So we take our function, 3x squared plus 2x minus 4, and we just simply set it equal to 0. Let's solve this using the quadratic formula. So looking at my quadratic function, my a value is 3, my b value is 2, and my c value is -4. Let's plug that into our quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4 times a times c, all over 2a. My a goes here, it's 3, and here. My b goes here, and my c goes here. So now everything is plugged in. Let's go ahead and simplify. So x is equal to -2 plus or minus the square root of 4. And then we have -4 times 3 times -4, which is a positive 48, all over 6. So x is equal to -2 plus or minus the square root of 52 over 6. And now, we are only going to use decimal values for now. When we get back into class, we will actually I'll show you how to use exact values, and I will show you how to simplify non-perfect square roots in chapter 12 actually, when we get back to that. So anyway, for now we're just going to use a decimal value. I got to grab my calculator, hold on. So we are going to rewrite this as x is equal to negative 2 plus or minus the square root of 52. I got 7.211. Let's do 7.21 over 6. And let's go ahead and get our final solution. So I'm going to bring this over here again, just because I'm running out of space. So x is equal to negative 2 plus or minus 7.21 over 6. And again, just like the last example, we have to take into account the two cases here. We have negative 2 plus 7.21. Let's go ahead and write that. So x is equal to negative 2 plus 7.21 over 6. And let's go ahead and solve. So negative 2 plus 7.21 is 5.21. Divided by 6, we get 0.868. So let's call it 0.87. We'll just round to two places for now. So that is the solution to our positive case. And we also need to take into account our negative case. So x is equal to negative 2 minus 7.21 over 6. That gives me x is equal to negative 9.21 over 6, or x is equal to negative 1.535, so negative 1.54. And that would be the solution to our negative case. So this is how we use the quadratic formula. Now, what we also have to talk about is the discriminant. So let's go ahead and move on to that. So, the discriminant. I'm actually going to go to our other side here. So we define our discriminant as b squared minus 4ac. Now, hopefully what you notice is that b squared minus 4ac, that sounds very familiar, okay? If you look at your quadratic formula, it is b squared minus 4ac underneath the square root. So let's talk about what happens there. If the discriminant is greater than 0, we will have two real solutions. Two real solutions, okay? So if we do b squared minus 4ac and our result is greater than 0, meaning it's a positive number, we'll have two real solutions. It doesn't tell us what our solutions are, it just tells us that we have two real solutions. If we do b squared minus 4ac, and that is equal to 0, we have one real solution. Okay? So if b squared minus 4ac is equal to 0, we have one real solution. And that makes sense if you think about it. I'll show you why in a moment. And last, if we have b squared minus 4ac is less than 0, meaning it's a negative number, we have no real solution. Just think about it. Since b squared minus 4ac is underneath the square root, if we end up with a negative number underneath the square root, then it's not going to be a real number. Do yourself a favor. Punch in the square root of -4 into your calculator and see what it tells you. It's going to give you an error because we can't take the square root of a negative number. So what we end up doing instead is if our discriminant is less than 0, to say it's negative, what we end up having is imaginary solutions. And don't worry, we are not going to cover that in Algebra 1. You'll cover that in Algebra 2. All right? So that's when we get into imaginary solutions, which again, we won't cover. If b squared is minus 4ac is equal to 0, and again, b squared minus 4ac is underneath the square root, so we're taking the square root of 0. Well, what's the square root of 0? It's just 0. So in our equation, when we have negative b plus or minus the square root of b squared minus 4ac, if it ends up being negative b plus or minus the square root of 0, well, plus 0 and minus 0 gives you the same number. Therefore, we'll only have one real solution. You'll see examples like that in your homework. And of course, if we have a positive number, we have 2. We're going to do plus or minus that square root, so we'll have 2 real solutions. So that's the discriminant. Let's look at an example. So again, the discriminant does not give us our solutions. The discriminant gives us how many solutions we have. So if we look at this example, we look at this example here. So they say find the number of real solutions to each quadratic equation. So for example A, we have 3x squared minus 2x plus 1, and I want to know how many solutions there are. So let's identify our A. Our A is 3, our B is -2, and our C is 1. And let's find the discriminant. So we are just going to do b squared minus 4ac. So let's plug in our information that we have. So b is -2, minus 4 times a is 3, c is 1. -2 squared is 4, minus 4 times 3 times 1 is 12. We end up with -8. So since my discriminant is less than 0, as you can see, the value of my discriminant is -8, we say that there are no real solutions. No real solutions. Okay? For this second example, we have 4x is equal to 4x squared plus 1. Let's get all of our x terms on one side. So I'm going to rewrite this as 4x squared minus 4x plus 1 is equal to 0. In this case, my a value is 4, my b value is -4, and my c value is 1. Let's find the discriminant. So b squared minus 4ac my b value is -4. Almost forgot my squared. That would have been an issue. My a value is 4. My c value is 1. So we end up with 16 minus 4 times 4 times 1 is 16. We end up with 0. Since my discriminant is 0, I know I have one real solution. And that's what we use the discriminant for. Again, the discriminant does not give us our solutions. The discriminant simply tells us how many real solutions there are. So that's everything I want to cover with you for 10.5. So let's take a look at our learning targets again. So we use the quadratic formula to find solutions of quadratic equations. We also use that quadratic formula to find the zeros of a quadratic function, which are kind of the same thing. And last, we evaluated the discriminant to determine how many real roots a quadratic equation has and whether it can be factored. We will talk more about whether it can be factored later. All right, class, make sure to look at your calendar, complete the homework, and we will see you on the next class period. Have a great day.